Hi, guys. This is moving on to medical probability, which, given the situation that we're in right now, is, I guess, a very interesting topic to discuss. I think we all would have preferred it would be less interesting um, and be in class at this time. So basically, what I'm going to do, I'm going to go page by page through the reading guide. And again, you can stop, review each page, work through it to the best of your ability to do so. Okay. So when we're thinking about medical testing and probability, kind of how those two things relate, most people, when we start thinking of a medical test, they really think that there's only two results. They have it or they don't. Okay. And by a medical test, we don't mean something like an x ray. We don't mean like them drawing your blood levels to see what they are. We mean for something like a flu test or a strep test or a test for the coronavirus. Okay. That's a very real example. So most of us think that when we go in, we're going to take this test. And if we have it, we're going to get a positive, and if we don't, we're going to get a negative. And that's really kind of only half the story because the majority of medical tests that we undergo typically yield what are called probabilistic results. Okay, now what does that mean? Getting a test result is only a probability of a condition. So if you test positive for the flu, 99.9% of the time, maybe you're going to have the flu, but not necessarily every single time. If you test negative 99.9% of the time, maybe you're truly not going to have the flu, but it's possible that you could have the flu and that's just a mistake. So we have to realize, and we don't always think about this, but really when we take a test, there are four outcomes that can be possible. We can have true positives, okay? And that's when somebody who tests positive actually has whatever it is that we're testing for. And then we can have false positives. And this is where we get a positive test, but this is someone who doesn't actually have it. So this is a correct result, and this is an incorrect result when we test positive. Okay. The same thing can happen for a negative test. We can test negative and truly not have whatever this disease is. That's a true negative. We also can get a false negative where we test negative, but we do have whatever this condition is. Okay. So false positives, positives don't have it. False negatives, negatives, but we do have it. Okay. So what is meant by the sensitivity of a medical test? Whenever a lab is developing a new test or trying to come up with a test for a specific condition, they have to really consider a couple of ideas about these tests. One of them that they have to consider is the sensitivity of a medical test. Okay. And that's the probability that someone who has this gets a positive test. Okay. So what you're really doing here is you're looking for the ability of a test to find a positive. Okay. So we want to make sure that we understand that's not necessarily the percentage of correct positives. But if someone who has it, what is the probability they're going to get a positive test? Now, how do you calculate that? Okay, and there's kind of a formula for this. The number of true positives that the test caught, true positives here, out of everyone who actually has it. Okay, so this will be the true positives. And down here, this will also be our true positives plus our false negatives because those people actually do have this condition. Okay, now highly sensitive tests, most everybody would think that means you would want the test to be very, very sensitive. However, I want you to think about it. If we're thinking about a very, very sensitive test, um, I could make a test that flagged everybody in the room positive. Okay. Now, the good part about that is that if somebody in that room actually did have this disease, I would get 100% of whatever I was testing for. But the downside of that is I'm going to get a whole bunch of people who don't have it as well. So tests that are highly sensitive have few false negatives. And if you have the disease, it's very likely to detect it. Okay. Specificity is the probability that someone who doesn't have it gets a negative. So this is the test's ability to find negatives. Okay. The formula for that is your true negatives divided by everyone who doesn't have it. So you're going to have your true negatives in the numerator, and then everyone who doesn't have it in the denominator. So that's going to be your true negatives and your false positives, because those people should have gotten a negative. Okay. For sensitivity, this is the percentage of people who had it that the test was able to find. For sensitivity, this is the number of people who didn't have it that the test was able to find. Okay? A test with high specificity would have few false positives, and if you're healthy, the test is very likely to confirm it. So again, I could give a test to an entire room full of people, and if it told them they were all negative, I would have 100% specificity, because everybody who truly did not have it would, in fact, have gotten a negative result. The downside of that is, though, that a lot of people who have this condition now think they don't, and they have a negative result. Okay, so let's consider this table below. This table comes from a study of a tuberculosis test, a TB test. Usually kids take these before they go to school. So here is an organization of some information here. We have this column of people who all have TB, and this column of people who do not have TB. Now, what would we hope in this test? Ideally, all of these guys would get a positive test, but we clearly see that they did not. In theory, in a perfect test, all of these guys would get a negative test, but we clearly see that they did not. Okay, we have some people who got incorrect tests. So these 571 test positive, and they have it. So here's my true positives. These 8 test positive, but they don't have it. So these are my false positives. These 259, they had it, but they tested negative. So these are my false negatives. And these 162, they tested negative and they don't have it. So this is a correct result. This is my true negatives. Okay. So if we're going to try to estimate sensitivity and specificity, okay, when I look at sensitivity, there's my true positives out of everybody who has it. Now, where did this 830 come from? It's the sum of this column. These are all of the people who have it and all of the people who should have gotten a positive result. So we got 69% of those. So that means it's about 69% sensitive. Okay. Now, specific. Here are my true negatives, 162 negatives out of 170 people. Here, that's this entire column, my true negatives out of all of the negatives. So all of the people who should have gotten a negative test, we found 95% of those. So that's our specificity there.